All right, here we are. Let's see how long it takes them to figure out their car alarm is going off. Okay, so if we see your watch take 12 seconds to register 10 seconds, how fast are you going? Well, faster than 0.5 because we just figured out that it's 11.5 seconds or something like that. If you go 0.5 the speed of light, right? So what we've got is we've got to solve this thing. T is T naught over the square root of 1 minus v squared over c squared, right? And we want to solve that thing for v. Now, rather than I would stick, in this case, I'd stick the 12 there, and I would stick the 10 there, and then we could just plug and chug and put numbers in. That's not pretty. So what I'm going to do is I'm going to show you what the solution is. And once you see the solution, it makes instant sense, and you can remember it. Because these formulas, the relativity formulas, are strangely fractal. That is, when you solve for things in them, they look like the thing that you solved out of or something. I don't know. You'll see. Words are failing me here. So what I'm going to do is I'm going to rewrite this way. Square root of 1 minus v squared over c squared is equal to t naught over t. So what I did was I cross multiplied and I divided. Okay, I know that this guy's over 1, right? And I can switch the numerator and the denominator on both sides. And I'm going to square both sides. So 1 minus v squared over c squared is equal to t naught squared over t, right? And then I'm going to, I guess I want this on its own side. So then I'm going to go 1 minus t naught squared over t squared. This was squared, right? Okay, because I squared both sides, right? Square. That was a step here, right? Okay, that equals v squared over c squared, right? And then I'm going to multiply both sides by c squared. So c squared outside of 1 minus t naught squared over t squared is v squared, and then all I have to do is take the square root of both sides, which looks like c times the square root of 1 minus t naught squared over t squared, and that's my velocity, okay? In general, this formula, when you solve for the velocity, notice how much this formula looks like this formula. Isn't that funny, right? And then they all do this, by the way. Even the relativity where you add the velocities, they do this, okay? In general, this formula has this form, okay? When you solve for velocity, it's c times the square root of 1 minus the small quantity, right, over the big quantity squared. Okay, so in the case of time, the 10 would be the small quantity, right? And the 12 would be the dilated time, right? In the case of length, it's of course the other way around. What the small quantity would be the moving length, and the big quantity would be the length when it's sitting still. If it's mass, it would be the total mass of it not moving over the mass of it moving, the dilated mass, okay? So we're just going to plug in here. So our velocity is c times the square root of 1 minus 10 squared over 12 squared, okay? And that's going to be, and all I'm going to do, I'm going to leave the c there because the answer should be in terms of the speed of light when you do these things. So I'm going to go square root of, simply square root 1 minus 10 squared divided by 12 squared. And I get 0.55277 c, right? We only have 2 sig figs, so we go 0.55 c. Ta-da. Okay, just remember, just memorize this. You don't want to sit there and do all that math on your test, okay?